So now we're going to look at the last way that we're going to have to solve log equations. Now, you know that you're this type if each term has a log or a natural log in it. So if you look at number 11, each term has a log. Number 12, each term has a natural log. So you know you're going to use this method if everything has the word log or natural log. Well, how do you solve these? Well, we're going to use the one-to-one property to solve them. The one-to-one property says if the log base a of m is equal to the log base a of n, then the arguments have to equal each other. It's kind of like when we got the bases the same in those exponentials, the exponents equal to each other. Well, here, if you end up with log base a on both sides, then the arguments have to equal each other. So how do we solve these? Well, again, just like last time, condense down to a single log on both sides of the equal sign. So first condense. Then we're going to set the arguments equal to each other and solve for x. And finally, just like we did in the previous examples, we have to check and make sure that our solution doesn't make an argument a number that's less than or equal to 0. If it is, we're going to have to discard that answer. Well, let's look at number 11. So the first thing that we want to do is condense down to one word log on both sides. Well, let's look here on the right. On the right-hand side, I am completely condensed. I only have log base 2 of something. But on the left-hand side here, I have 2 logs. So I need to condense these down to a single log. Well, what's the property when I'm adding? Remember the product rule says if you're adding, then you can multiply your arguments. So this becomes the log base 2 of 5 times x minus 3. And that's still equal to the log base 2 of x plus 5. Well, now did I completely condense down to one log on both sides? Yes, the left has log base 2, the right has 1 log base 2. So now because I have log base 2 of something equals log base 2 of something else, according to the one-to-one property, I can set these arguments equal to each other. So I'm going to say that 5 times x minus 3 is equal to x plus 5. Solving for x, go ahead and distribute your 5 here. So 5x minus 15 is equal to x plus 5. Well, let's just solve this equation, bringing x to the left. 4x minus 15 equals 5. Add 15 to both sides. 4x is equal to 20. Divide both sides by 4, and x is equal to 5. So for my first problem, x is equal to 5. But then I have to go back and check, does this make any of my arguments less than or equal to 0? Well, I go to my first argument, which is this 5. Well, there's nowhere to plug a variable in there, so there's no way that 5 is going to be a number less than or equal to 0. My second argument, x minus 3, if I were to plug a 5 in there, so 5 minus 3, which is 2 a number that's less than or equal to 0? No, so that's fine. The last argument is x plus 5. So 5 plus 5, which is 10. Is that a number that's less than or equal to 0? No, 10 is bigger than 0. So that means that this answer checked out, and my answer is x equal 5. Let's look at example 12. Same thing as before. The very first thing we need to do is condense down to a single log on both sides of the equal sign. I'm fine on the right-hand side, but on the left-hand side I need to do a little bit of work. I have the natural log of x minus 1 plus the natural log of x. Well, that's the product rule. The product rule says that if you're adding, you can multiply the arguments. So that's going to be x minus 1 times x equals the natural log of 2x. Well, now what you want to do is use the one-to-one property that says if you have a log base a, or natural log in this case, on both sides, then the arguments have to equal each other. So let's set those arguments equal to each other and solve. Well, this is going to be x minus 1 times x is equal to 2x. Distributing on the left-hand side, I get x squared minus x is equal to 2x. Well, this is a quadratic, so I need to get it equal to 0. Subtract 2x from both sides. X squared minus 3x is equal to 0. If I factor out an x, I get x times x minus 3 is equal to 0. Solving them both, x is equal to 0, and the other one is going to be x is equal to 3. But I'm not done. I need to go and make sure that these answers don't make my arguments numbers that are less than or equal to 0. Let's start with the first one. X equals 0. If I plug 0 into x minus 1, so that would be negative 1. Is negative 1 something that is less than or equal to 0? Yes, because the argument less than or equal to 0, this answer gets discarded. Right? What about x equals 3? Well, I plug 3 into x minus 1, that's 2. 2 is not a number that's less than or equal to 0. Plugging it in for x, again, that makes 3. 3 is not less than or equal to 0, so that's fine. And the last one, 2x, so that would be 6. Well, 6 is not a number that is less than or equal to 0, so 3 checks out, and our only answer is x is equal to 3. All right, let's look at the last example, which is example 13. So example 13, natural log of x plus 1 is equal to the natural log of x plus 9 minus the natural log of x. First thing I need to do is condense down. Well, the left-hand side here is fine, but the right-hand side needs to be condensed. Well, what do I do when I am subtracting my logs? When I'm subtracting, I can divide the argument. So I end up with x plus 9 over x. Well, now I have a single log on both sides of the equation, so I can set those arguments equal to each other. So I get that x plus 1 is equal to x plus 9 over x. Well, this is a rational equation. One of the easiest ways to solve a rational equation is cross multiply. So x plus 1 times x is going to give you x squared plus x. Cross multiplying the other side, x plus 9 times 1 gives x plus 9. Well, now what you need to do is you need to again solve for x. Well, this is quadratic, so I need to get it equal to 0. If I subtract x from both sides, I end up with x squared is equal to 9. Well, I can use extraction of roots to solve this because it's just a squared equal to a number. If I take the square root of both sides, x is now equal to plus or minus 3. So I have two answers. One is x is equal to positive 3, and the other one is that x is equal to negative 3. So let's check and make sure that they work. The first one, let's plug 3 in here. 3 plus 1, is that a number that's less than or equal to 0? No, because that's 4, and 4 is bigger than 0. 3 plus 9, that's 12. 12 is bigger than 0. We're okay. Last one, 3. 3 is bigger than 0. So this number works, and we don't have an issue with that number. What about negative 3? If I plug negative 3 into this argument, negative 3 plus 1 is negative 2. Is that a number that's less than or equal to 0? Yes. So I must discard negative 3, and my only answer here is x is equal to 3. So again, there are two ways to solve exponential equations. The first type is to express both sides with the same base and then set the exponents equal to each other. The second type, where you can't express both sides with the same base, and you take the natural log or the log of both sides to solve. For log equations, if each term in your equation doesn't have the word log or natural log, you can condense down and use the definition of logs to solve. And for the last one, if every term has the word log or natural log, you can condense down and then set the arguments equal to each other. That's it for exponential and logarithmic equations.